Hi, good day and welcome to the Ellen Degenerative Show. Well, we all heard about this mad cow disease, and so I went to the farmer to ask him how can he differentiate between a normal cow and a cow with mad cow disease. Well, he said the normal cow would sound like this, but the cow with the mad cow disease would sound like good stuff. Well, today our guest is on the cover of Exciting magazine. So let's welcome Lady Protein. Okay, Lady Protein. I've heard from a little birdie that you've got a new music video coming out soon. Tell us a little about that.
Well, everybody knows me to be a good protein, and I do good things for the body, like make enzymes, collagen, keratin, and the list just goes on and on and on. But I want them to know about my bad side. You know, when I misfold up in this place.
Misfold, you say? Protein folding and misfolding. Where does protein folding occur? Well, synthesis of protein occurs on the ribosome via translation of the mRNA. But we already know this. Sometimes folding of protein occurs while it is being translated. Therefore, it is called co-translational folding. Sometimes folding may occur in the cytoplasm, the mitochondria, or the endoplasmic reticulum. But this would mean that incompletely folded proteins will be exposed to solvents at some point, making them prone to inappropriate reactions with other molecules. This is where the chaperone comes in to ensure that folding is completed more efficiently. They can either interact with the Nansen chains as they emerge from the ribosome, or may be a guide in stages of folding processes. The GRO-EL is a particular class of chaperones containing a cavity where incompletely folded polypeptide chain can enter and complete its final step in the formation of the intended structures while being protected from the outside world. As a result, chaperones are able to increase the efficiency of the overall process by reducing the chances of other competing reactions. They can also rescue misfolded proteins and allow them to have a second chance to fold correctly. ATP is required for this. Proteins that are meant to be exported out of the cell is sent to the endoplasmic reticulum. Here, folding takes place, and then it is secreted via the Golgi apparatus. This mechanism involves a series of glycosylation and deglycosylation reactions. This enables correctly folded proteins to be distinguished from misfolded ones, which can then be tagged for degradation. Proteins that fail to fold correctly often give rise to malfunctioning of the living system and hence lead to diseases. In other cases, proteins with a high tendency to misfold escape all protective mechanisms and form intractable aggregates within the cell or extracellular spaces. Also, I see chaperones help prevent you from misfolding, kind of like a strict parent. But you mentioned that you have the tendency to misfold and get loose and cause diseases. Tell us a little about that.
Well, hon, sometimes I'm unstoppable. You ever heard about Alzheimer's disease, mad cow disease, or cystic fibrosis?
Yep.
Well, guess what? I'm the cause of that.
Alzheimer's disease. Alzheimer's disease has been identified as a protein misfolding disease. It is caused by the accumulation of abnormally folded amyloid beta and amyloid tau proteins. APP mutation causes APP mismetabolism to take place. APP is then split by enzymes B secretase, then Y secretase. Some of the fragments that result stick together and form a short chain of oligomer. Oligomers are also known as amyloid beta derived diffusible ligands. Oligomers of amyloid beta 42 have been shown to cause problems in the communication between neurons. Amyloid beta 42 also produces fibers or fibrils. When they stick together, they form amyloid plaques. Some of these plaques can insert themselves or diffuse into the membrane of the neuron, causing substances outside the cell to leak into it. This causes further damage. The damage results in a buildup of amyloid beta 42 peptide, leading to neuron dysfunction and cognitive impairment, as we can see here. The second major finding in the Alzheimer's brain are neurofibrillary tangles. Neurofibrillary tangles are composed of a protein called tau. Tau proteins play a crucial role in the structure of the neuron. Neurons possess cytoskeletons which comprises of microtubules. These microtubules aid in guiding the transport of nutrients and molecules from the body of the cell to the axon and then back. The protein mentioned, tau, stabilizes the microtubules when phosphorylated and hence is called microtubule-associated protein. However, in Alzheimer's disease, the tau protein undergoes chemical changes, then becoming hyperphosphorylated. This causes it to begin to pair with other threads, forming neurofibrillary tangles and disintegrating the neuron's transport system. Thus, in people with Alzheimer's, tau proteins cause abnormality through overactive enzymes, resulting in the formation of neurofibrillary tangles. Neurofibrillary tangles then result in neurological dysfunction or even death.
Evidence has shown that the infectious agents associated with certain diseases of the brain, such as Creutzfeldt-Jakob disease in humans and mad cow disease in animals, may be a protein. This agent is called a prion, or a proteinaceous infectious particle. The normal prion protein, PRPC, is found on the membranes of neurons, as seen here. A misfolded PRP can cause a normal PRPC to become misfolded by introducing amyloid folds in its structure. When a misfolded PRP enters the brain, it binds to the normal PRPC and causes it to misfold. The newly misfolded PRP then converts more normal PRPC proteins to the abnormal form. This infection causes the disintegration of neurons in the brain and holes appear that looks like sponges, hence the name bovine spongiform encephalopathy. The infection has no cure and can be fatal. A healthy cow can become infected by eating contaminated foods, which then becomes a mad cow. A mad cow can then infect humans when they eat the infected beef, as seen here.
Cystic fibrosis. Cystic fibrosis is an inherited disease caused by a genetic mutation on the 7th chromosome. So what does this mean? Well, a defective gene results in abnormalities in the production and function of a protein called cystic fibrosis transmembrane conductance regulator, or CFTR. Cystic fibrosis in the lungs. In healthy cells, CFTR acts as a chloride channel as well as a regulator of sodium by inhibition of the sodium channels. Therefore, if the CFTR is inactive or insufficiently functioning, this results in impairment of chloride transport and an enhancement in sodium absorption. Therefore, due to the high concentration in the basolateral membrane, H2O from the airway surface liquid will diffuse out, causing the apical membrane to become more viscous. Because of this, cilia, which is able to move fluidly when in a normal healthy cell, will be unable to move due to the viscosity. This will therefore cause a build-up of bacteria in the mucus layer. As a result, this would cause an infection in the lung. These are some complications that is caused by cystic fibrosis. First, we have chronic sinusitis, nasal polyps, respiratory tract infection and bronchitis, liver disease, portal hypertension, gallstones, distal intestinal obstruction syndrome, steratoria, male infertility, osteoporosis in the bones, finger clubbing, pancreatic insufficiency, diabetes, and abnormal sweat secretions due to the high sodium and chloride. Well folks, that brings us to the end of our show, and guess what? Everyone is going to get a free copy of this month's Excited magazine. Plus, Lady Protein has a special announcement.
Let's get ready to boogie! Cause I'm gonna premiere my new music video, Protein Misbehavior.
Woo!
protein misfolding disease can be split up into two main classes. First class is the Prion. Mad disease, the familiar one. Next, amyloidosis, Alzheimer's disease, the famed popsulate mutation in gene CFTR protein, no major crisis, cystic fibrosis. Mad cow disease caused by the prion protein pre-RPC. It's resistant to proteolytic degradation in typical brains when PRPC falls normally. We stay healthy. Mutation in PRPC gene allows the protein to be made the wrong way, and it will misfold, making a PRPSC prion. These prions, when exposed to PRPC that are folding, inspires that PRPC to fold belly as well, creating another PRPSC. The good PRPC has alpha helices, the bad has beta pleated sheath. Cells are built up of normally folded amyloid-beta and amyloid proteins. In the brain is the cause of Alzheimer's disease with the part of amyloid plaque. The piles of bits, A, B, and P from APP. In a healthy brain, these pieces are degraded and then kicked out. In Alzheimer's disease, pieces pile up and form insoluble plaques. Neurofibrillary tangles and soluble twisted fibers in the brain cells. The tangles mainly consist of the protein, so in its healthy form it is in the assembly of the macrotubular structure. These tubules facilitate the movement of nutrients and other vital things from one part of the nerve cell to another. In Alzheimer's disease, however, the protein is abnormal, and it causes the microtubule structures to collapse. What we know about cystic fibrosis, it's an inherited disease caused by a genetic mutation on chromosome 7. The defective gene results in abnormalities in the production and function of the CFTR protein Most common mutation is the deletion of 3 nucleotides, which results in the loss of the amino acid phenylalanine. As a result, the protein does not fold normally and is more quickly degraded. Also, CFTR protein is an ABC gene.